Welcome to this series on the Cisco Unified Wireless Networking Solution. In this series of videos, we are looking at secure authentication on the wireless infrastructure using EAP-PEAP or EAP-TLS with the radius on the ACS or directly on the controller. In the first video, we had a look at EAP-TLS and said that EAP-TLS was a very secure authentication method. The downside of EAP-TLS is that you have to have a certificate on each and every single client. And this may create a burden on the network administrator if you have thousands of clients in your network, where every day there is a new client to be added or a new client to be removed. So the market was looking for a simpler solution. And there is one, which is called EAP-PEAP. So with EAP-PEAP, we pretend that we are doing EAP-TLS because EAP-TLS is very secure. So when the EAP process starts, the authentication server sends a certificate. So the authentication server needs to have a certificate. And the client in EAP-PEAP pretends that it is doing EAP-TLS and returns what looks like a certificate. But it's not a certificate in the sense of being something generated and signed by the certification authority. It's just a value that will be used by the authentication server to send encrypted data back to the client. So it looks like a certificate, but it's not a certificate. So it's not something you need to generate for this client. And as we're doing this EAP-PEAP process, the authentication server accepts this value as being a valid encryption method, even though it's not really a certificate. But from the outside observer, we are doing a pure EAP-TLS process here, and we know that this is unbreakable. But in reality, we do send a certificate from the authentication server, and the authentication server does receive something from the client that will be used to encrypt data back to this client. So we create a tunnel. And within this tunnel, we do a second time an EAP authentication. Within EAP, that's why it's called PEAP, protected EAP, because it's EAP within EAP. And in this secured second authentication process, the client actually uses something like a generate token card or username and password pair to authenticate. So within the tunnel, the authentication server does send the certificate a second time. But this time, the client, instead of pretending to send a certificate, sends its real credentials, which are based on the username and password pair or a generic token card. Again, the second phase is hidden, so from the outside, we think that an EAP-TLS was conducted, and all the rest, what is within the tunnel, is just data exchange between the authentication server and the client. So this is almost as secure as EAP-TLS and a lot lighter because you do not need to have a certificate on the client. You just need to have one certificate on the authentication server. And then you need to have username and password pairs or generic token cards for clients. So this shows EAP-TLS in the first video and in the second video EAP-PEAP. Now, how do you configure this? What do you need to do to configure EAP-TLS first? So as you remember, EAP-TLS all relies on certificates, and the key in EAP-TLS is to be able to trust the certificate that is being sent from one side, because this certificate is a public key with which one side is going to encrypt data to send back to the other side. So when the authentication server sends a certificate to the client is going to use the certificate to encrypt data and send it back to the authentication server. So the client needs to make sure that the key that is being sent, the certificate that it's receiving, is actually sent by the real authentication server, so that it doesn't send encrypted data to someone else that may be able to decrypt this data. So that's why EAP-TLS relies on a certification authority signing process by which this CA, certification authority, certifies that this certificate is genuinely coming from who it pretends to be coming from. Authentication server on one side, client on the other side. So to configure EAP-TLS with the Cisco wireless infrastructure, you need first to get a radio server, typically the ACS, but we'll do also the controller to show you how it works. But a radio server somewhere that is going to generate a certificate. That's of course generating in fact a pair of keys. One public key, which is the certificate and is used to encrypt. This key will be sent to the client so that the client can encrypt with this key. And of course a private key that the authentication server will keep for itself and that it will use to decrypt what will be sent back from the client. So we generate this certificate first on the radius. As of course the client does not know this radius yet, we'll need to send the certificate from the authentication server to a certification authority that is going to sign this certificate, that is to say certify the validity of this certificate. And of course we'll get this signed certificate back to the radius and install it on the radius server. Of course, as the certification authority is signing this certificate, testifying that this certificate is real, we'll also need the client to trust this signature. So we'll need to install the certification authority signature somehow on the client, so that when the authentication server sends the certificate to the client can say that this is a real signature from the certification authority that can be trusted. I have a question mark on this step number 4, as you can see, because all this depends on if you have the client verify the signature or if you want the client to blindly accept any signature from any certification authority. You have both possibilities, and we'll show you both in the demo. But that's, I would say, a good security mechanism to add. So that's for the authentication server part. On the client part, it's the same process. You need to have a certificate generated for this client, and you need to have the certification authority sign this certificate. And then of course you have to install this signed certificate on the client. And same as the other way back, you probably will have to install the certification authority signature somewhere on the radius server, so that when you send a certificate from the client to the authentication server can testify that the signature verifies the validity of the certificate. So that's the EAP-TLS to-do list. For the EAP-PEAP, it's actually a little bit simpler. It's the same process on the radius side, because the radius has a certificate. So same process, you generate a certificate, have it signed by the CA, then you re-import it to the authentication server, and of course you may want to add the signature of the CA into the client so that the client can verify the validity of the certificate. But of course for the client side, as you're relying on the username and password pair or generic token card, the only thing you really need to do on the client is, apart from installing the CA signature, is to create a username and password pair and make sure that the radius server knows this username and password pair somehow, because you're creating this name on the radius itself, or because you tell the radius where to verify this username and password pair. So that's the menu. In the next video we're going to do it on the ACS and on the client, and we're also going to try to do it on the controller itself.